Good morning, everyone. Myself, Captain Prabhakaran, Assistant Professor of SRM William Engineering College. Now we are seeing discrete mathematics, chapter number 2. In particularly, chapter number 2. Today we are seeing the topic is principles of inclusion and exclusion. Principles of inclusion and exclusion is purely set theory. First of all, what is the definition of set? Set is called a collection of well-defined objects. What is the meaning of well-defined? தமிழ்ல சொல்லணும்னா நன்கு வரையறுக்கப்பட்ட. For example, we are all engineering students. Is a mass or universal set. We are all engineering students. In particularly, we are the engineering students means SRM William engineering students is a subset. Engineering set, you are engineering students, and in particularly SRM William engineering student. SRM William engineering students is a subset of engineering students. In particularly, SRM William engineering students, we are the CSE, computer science students. Computer science students is a subset of SRM William engineering college students. So in particularly, we are all computer science students in section 3. So that is called well defined. That is called the well defined. நன்கு வரையறுக்கப்பட்ட. The set is called the well defined objects. In mathematically, you say about in very clearly, the for example, natural number, set of natural numbers, set of whole numbers, set of integers, set of rational, set of irrational, and this is these sets are collection of subset of real number. That is called the set. Set is called collection of well defined objects. In particular, gender wise, maybe in the class, your class, so boys and girls. That is also called the collection of well-defined objects. That is, object mean here human being, otherwise a number. And what is, suppose that in a set, and what is the number of elements in a set is called the cardinality of set. Is called the cardinality of sets. Simply say that cardinality of sets is the notation is n of a. In higher education, we are come to the is modulus of a. So inclusion exclusion of two sets, any two arbitrary sets to take. First of all, the arbitrary sets is a non-empty. What is the meaning of non-empty? Some element in a set is called the non-empty. First of all is a take your non-empty sets. Modulus of A union B is equal to modulus of A plus modulus of B minus modulus of A intersection B. Here number of element in set A union B is equal to number of element in set A plus number of element in set B minus number of element in set A intersection B. Is cardinality of set, that is called the number of element in set A. N of A is called the cardinality of sets. In particular, you will find out the complement of a set is equal to modulus of A bar is equal to total number of elements minus number of element in set A. That is called the inclusion exclusion of two set. In specific formula, modulus of A union B is equal to modulus of A plus modulus of B minus modulus of A intersection B. Now we are seeing the problem. Let S a set of integers. S is a set of integers from 1 to 1000 that are multiple of 3 or multiple of 5. Now we are defined A is a set of integer 1 to 1000 that are multiple of 3, and set B, that is the set of all integer 1 to 1000 that are multiple of 5. It's clear that S is a union of A and B, but notice that A and B are not disjoint. A and B are not disjoint. So now we are find out the number of element in multiple of 3 in set A, that is called the cardinality of set A is equal to 1000 divided by 3. Very clearly, multiple of 3 means is a divisible 3 is exist. So n of A is equal to 1000 divided by 3 is equal to 333, 333. And cardinality of set B is equal to 1000 divided by 5 is equal to 200. A intersection B is a set of integers that are multiple of 15. That is called the LCM of 3 and 15. 5. Sorry. and A intersection B, that is the cardinality of set A intersection B, is equal to 1000 divided by 15 is equal to 66. Now we are using the formula of inclusion and exclusion principle. Modulus of S is equal to, that is called modulus of S, means modulus of A union B, cardinality of set A union B is equal to cardinality of set A, cardinality of set B minus cardinality of set A intersection B is equal to 467. That is the final value. Now we are going to the inclusion and exclusion of three sets. That is called cardinality of set A union B union C is equal to cardinality of set A plus cardinality of set B plus cardinality of set C minus cardinality of set A intersection B minus cardinality of set A intersection C minus cardinality of set B intersection C plus cardinality of set A intersection B intersection C. They simply say that modulus of A union B is equal to modulus of A plus modulus of B plus modulus of C minus modulus of A intersection B minus modulus of A intersection C minus modulus of B intersection C plus modulus of A intersection B intersection C. That is the inclusion and exclusion of three sets. Now we are well and clear the formula. Now going to the problem. From total number of students is a 50. In a 50 students, for example, your classroom, in a 50 students, cardinality of set A, the set A defined as the cardinality of set A is 3 no Java. 30 பேருக்கு Java தெரியும். And remaining B set is 18 no C++. 18 members know about the C++. And cardinality of set C is know about the C. Now A intersection B means Java and C++ know the students. Number of students is a 9. And the cardinality of set A intersection C is a know about Java and C is a 16 student. Number of students is a 16. Know about the Java and C. The finally A B intersection C is equal to 8 number of students both C++ and C. C++ and C. Now finally A union B union C is a, you know what is the meaning of A union B union C? At least one language, maybe Java and C++ and C is a 47 students, is a mass community. At least one language is know about. So finally we find out the how many know all the three language. So in a total number of 50 students, how many students studied or know Java and C++ and C? Now we know about the very clear the formula of inclusion and exclusion of three sets. Modulus of A union B union C is equal to modulus of A plus modulus of B plus modulus of C minus modulus of A intersection B minus modulus of A intersection C minus modulus of B intersection C plus modulus of A intersection B intersection C. Now very clear, the at least one language means A union B union C, the total value is 47 and 30 is cardinality of set A, 18 is cardinality of set B plus 26 is a cardinality of set C minus 9 for both Java and C++, minus 16 were both Java and C, and minus 8 is both C++ and C. Finally we find the value of know about all the three language, cardinality of A intersection B intersection C. Finally we get the value using the calculator. 47 minus 30 minus 18 minus 26 plus 9 plus 16 plus 8, the final answer is 6. 6 number of students know about the three languages, Java and C++ and C. And next is the inclusion exclusion of four sets. Inclusion exclusion of four sets: A union B union C union D, that is called the cardinality of set A plus cardinality of set B plus cardinality of set C plus cardinality of set D minus A intersection B minus A intersection C minus cardinality of A intersection D minus cardinality of B intersection C minus cardinality of B intersection D minus cardinality of C intersection D. Now finally now go to three sets: plus A intersection B intersection C plus A intersection B intersection D plus A intersection C intersection D, finally plus B intersection C intersection D minus A intersection B intersection C intersection D is a cardinality of sets. That is the inclusion exclusion of 4 sets. Inclusion, exclusion of 4 sets. So finally this is the formula of general formula of n sets in inclusion exclusion. That is the general formula of inclusion. Suppose that you have a n number of sets, maybe 10 sets, you will find out easily the formula of inclusion exclusion. And for example, in a 3 sets A1 and A2, A3, the A1 is defined 2, 3, 7, 9, 10. And A2 is a 1, 2, 3, 9. And A3 is a 2, 4, 9, 4. For S is a collection of sets. This is the overall set. S is a 1 to 10 numbers. The following table summarizes the sum. For example, A1, A2, A3, how to find out the A intersection, A1 intersection A2 and A1 intersection A3, A2 intersection A3. So finally get the answer. That is called the very easy to solve. A1 union A2 union A3. Finally, find the number of mathematics students at the college taking at least one of the language Telugu, Hindi and English. Given the following data, already be very well and good and clearly for Java, C++ and C the same model problem. 65 studied Telugu, 45 studied Hindi, 42 studied English, 20 studied both Telugu and Hindi, 25 studied Telugu and English, 15 studied Hindi and English, 18 studied all the three languages. Find the at least one language. You will find out that at least one language means n of A union B union C. That is called here say about the T for Telugu, n of T, H, n of H is Hindi, number of Hindi studied the student 45 and n of E is a number of studied student in English. So finally the definition already we know that n of T union H union C is a inclusion exclusion principle of 3 sets. Inclusion exclusion of 3 set n of T plus n of H plus n of E minus n of T intersection H minus n of T intersection E minus n of H intersection E finally plus n of T intersection H intersection C. You will substitute all the values, number of students studied Telugu, Hindi, English and both Telugu and Hindi, Telugu and English, Hindi and English. Finally get the answer. Number of students at least studied in one language is 100 students studied the one language. That is the final answer. This is very clear. We are all method of inclusion and exclusion. Thank you, students. We are seeing next class. Thank you so much.